All right, so let's move on to the next presentation by Dr. Sarso, Dr. Domingo Sarso, Director of IDA and Technical and Innovation Manager for Water. Domingo, please connect your video and let's see your presentation in 10 minutes.
It's connected. Good afternoon, everyone. Thank you. This is the first. Okay, thank you for the organization for inviting me to this conference inside the Indian Water Week and all the attendees for being here today. My presentation will be focused today on Spanish desalination and its extensive use for agriculture. Okay, Spain is a country with water scarcity, mainly the Mediterranean coast, and we have been using extensively desalination for facing this scarcity. Spain is the fourth country in installed capacity worldwide, and it has also a very strong industry with 8 of the 20 largest companies in the world. Next slide, please. Okay. The first desalination plant in Spain was built in 1964, curiously the year I was born, in Canary Island. And since then, the capacity has not stopped growing, with the remarkable milestone of the Agua program in 2005, with the construction of many large plants from the government, and including all kinds of desalination plants with different technologies, RO, EDR, etc., and water sources, including wastewater, which means tertiary treatments for reclaimed water. Next slide, please. On the other hand, Spain has a strong agriculture, demanding the 75% of water demands, and it represents more than 25% of total agricultural land in the European Union and a 5% of the Spanish economy. Curiously, it's mainly widespread in the Mediterranean region where we have the highest water scarcity. For this reason, Spain is the largest user of desalinated water for agriculture, with approximately the 21% of the global production of desalinated water, while it's less than 3% globally, which means almost irrelevant. Next slide, please. Okay, in this slide, I would like to show you the desalination production of the largest plants from the Spanish government. Since the implementation of Agua program in 2005, 1,400,000 cubic meters have been produced, representing 43% for agriculture. This percentage has been growing, representing the 55% in 2008, and is still growing each year. These plants are the large installation from the government, from the Agua program, but there are many other plants from private initiatives. We have even farmers with their own desalination plants for their crops. Next slide, please. You can see in this slide the price difference between the different water sources in the Segura River Basin in the southeast of Spain, in the Mediterranean area, one of the main areas for agriculture. You can see that the desalination prices are much higher than water from other origins, from superficial or groundwater, etc., around 0.8 euros per cubic meter, which is almost double or triple than water from other origins. Although we think that this could change in the future with water scarcity and the effects of climate change. Next slide, please. Okay, this slide is interesting because we are showing the economic productivity of water. You have different crops in the table and the price of the productivity of land, kilograms per hectare per year, economic productivity of land, euros per hectare per year, and the economic productivity of water, euros per cubic meter. What this means? Economic productivity of water represents the profit achieved by each cubic meter of water supplied. This means that in theory, products with an economic productivity higher than 1 or 1.5 could afford the price of desalinated water. We have also to take into account that in this region, there are many farms with high-tech greenhouses, hydroponic crops, and effective irrigation with recirculation systems. And I would also like to remark that for this kind of agriculture, water can represent something between 5–10% of the overall production cost, which means that for many crops it's feasible to use desalinated water, even from the desalination plant, which means pure without mixing. Next slide, please. Okay, we have been speaking about the prices of pure desalinated water, but the reality in this region is different. Is that the farmers are traditionally using blending of water from different origins, superficial, groundwater, reclaimed water, and desalinated water, to produce a cheaper irrigation water. In the map, you can see the south of Almeria province with many different installations. You have seawater desalination plants, brackish water desalination plants, wastewater treatment plants, etc. The blend, on the other side, you are producing water at cheaper cost, but on the other hand, blending reduces other kind of risk from the use of desalinated water, such of boron concentration or the sodium absorption rates, which means that you are equilibrating water or remineralizing water with this blending. Next slide, please. Okay. In this example, is from one irrigation company of end users. You can see the prices from different sources with the conductivities and flows. In this case, is a 30,000 cubic meters per day brackish water RO plant, but they are blending desalinated water with other, obtaining a cost, an overall cost below 0.2 euros cubic meter instead of the cost of 0.34 of from the desalination plant, with a reasonable salinity. I will also to say that in this plant, water is produced a la carte, blending different proportions of water depending on the crops of the season. And they are using also the capacity of storage in order to have advantage for obtaining better prices for energy, avoiding peak periods. Or recently, we have installed, for example, an arrow train fed by water coming from a source located at high level, which means working without high pressure pump, with the pressure fed by the difference of level, which means close to zero energy consumption. That means that the agriculture is very innovative in reducing the cost of water for agricultural production. Next slide, please. Okay, the current situation in this region is most of the small units built during the 80s and 90s of the past century by farmers are not in operation. They are mainly receiving water from the large government plants. Large government desal plants are supplying desal water, although not a full capacity. They are supplying water for drinking water and also for agriculture. And new large plants from the government are not expected in Spain because the needs of drinking water in the coast are covered. In October 2015, the Spanish government decided also to reduce the price of desalinated water for farmers, initially and temporarily in Murcia region around 0.3, which means something like a subsidy of the desalinated water. Currently, there are some groups of farmers and big companies promoting the construction of two new large desalination plants between Murcia and Almeria, exclusively for agriculture. Of course, the best solutions are always mixed solutions, including different water sources, transfer, reuse, groundwater, and desalination, and management strategies. Next slide, please. This Borja. This is
2 minutes.
The last one. Okay, sorry because I have been very fast, but I want to maintain the time. Okay, as a conclusion, food supply is a strategic element for any country, and a desalination-based agricultural production can ensure it. Desalination should be another common tool for ideological planning for the politicians, and it can coexist with other water sources. Many crops can support the price of desalinated water without a significant impact in the overall product price. All the possible technical issues you can think about, environmental effects on soils, boron, etc., can be solved with investment, which means that the key factor for the feasibility is always water price. And the Spanish experience has demonstrated that desalination is a feasible alternative for both drinking water and agriculture, and can be incorporated in the overall production costs.
I like how your tomatoes and peppers look like membranes in the picture.
Thank you. Thank you very much.
Thank you, Domingo. Great, excellent timing. Okay, let's move on to the last presentation of today, which is going to be delivered by Mr. Nayan Shah, a member of IDA, Sales Director of ID Technologies in India. Nayan, go ahead. Please turn on your video.
Yeah, I'm there. Thanks, Boka. So good afternoon, friends in India. Good morning, good afternoon for the team joining from US, Europe, or Israel. So thank you, first of all, IDA and Smart Water and West Alliance in terms of organizing this and giving this opportunity. So can you go back? Can you go back? Yeah. So it's like the opportunity to cover the innovation on the desalination. So in next 8 to 10 minutes, I'm planning to cover two of the major important innovation from IDE and which are very relevant when India is building its desalination dream. It's like some of the critical desalination infrastructure are under execution or under planning stage. So two major levers for desalination in India could be cost and the convenience. So one end we are seeing that how we can bring down the cost of the operation, cost of the capex. And other side, we look at the convenience of building it, running it, and it's like fitting the local conditions. So we all know the reverse osmosis is the main energy consumer. It's like 45 odd percentage of the OPEX goes into the power consumption. And some of it can be mitigated by the long-term contract of the renewables and all those, the alternative energy sources. But still the large portion of the desalination works on the electrical consumption through the grid and all. So it's like way back in 2005, the IDE built the plant in Escalon and decided to adopt something which is part of the process theme, and that's how the birth of pressure center concept comes in. So it's almost around 15 years now. The plant we experimented this was 330 mld of desalination. Can we go to the next? So one aspect, it is like the pump is available, which is like if you select the 1000 meter cube per hour kind of a pump available at 86% of the efficiency. And if you move it up, it can be the higher the capacity, the higher the efficiency. This could be harnessed. So here we tried moving from 1000 meter cube per hour pump to a 2500 to 2800 meter cube per hour. And that particular, the 2% delta, what we could push up, right, resulting into around 3% of the saving. And we can see that, we have seen the chart that Devesh presented and earlier the Carlos put in terms of how over a period of time, the power consumption across the desalination has come down. So this is one of the major aspect of it. When we talk about the cost per meter cube or the specific energy consumption per meter cube, this has the major impact. Now let's understand the challenge and the change. Can you please move to next? So for small and medium size, if the desalination, when I say the small and medium is like anywhere between less than 100 mld. So for that plant, the simple scheme is more simpler, ease of operation would be there, and it gives the great convenience and to adapt the individual skid configuration. So no two doubts, even the smaller plants, this is still the valid design concept and might not really, the risk and rewards are not being balanced if we move to the pressure center. Can we go to the next, please? But for the large plant, when I say the 100 mld and up, where the higher availability, the flexibility of the operation, then the cost of water production, even the ease of maintenance are the major driver in terms of your decision making. These are the factors which really, these are part of the pain matrix of the operation of a plant. So then the pressure center concept can be a very rewarding experience. As in the single trade, the pressure center also has the three main components. It's like, you have the membrane, you have the high pressure pumps, you also have the energy recovery device. But instead of having a large number of small and separate skids, here it is like the integrated and large, individual unit. The components are arranged in three dedicated, separate, and independent. sections working synergistically between them. So what it adds in here, it adds a great deal of convenience, and even can we move to next, please? Even the small delta on the efficiency, right? Here we can see that like 1,000 meter cube per hour to a 2,500. Even we now pushed up to 3,300, 3,600 meter cube per hour kind of pumps. So even the smallest delta on that particular aspect, we know the multiplication factor is very high because it's going to run for 24 hours and across the year. So can result into a great saving. Can we move to next? So yeah, this is the footprint. Even the footprint is look neat, and even on the flexibility of operation is easy. The varied power tariff, I'll highlight one critical aspect of it. It's like it's a more prevalent in Israel, but we see that going forward, the grid concept will be there. So based on the demand, the tariff will vary. So if you have a peak of a demand and the tariff is also at peak, you're going to lose more. So when this is the independent desalination plant, integrated contracts, we try to see that when the off-peak tariff, I would like to run at the most, at the highest rated capacity. And when the tariff is at peak, I'll see that I'll actually throttle down. So this kind of a flexibility also, if you are looking at this, designs can be a great advantage. Another thing is like when simply look at the membrane life. The pressure center concept can allow to operate at much, the lower recovery when you fully put the entire unit in operation, resulting in the lower osmotic pressure and producing at the lower permeate flux. So the entire available membrane area is high. Your per meter cube cost can be brought down. So again, I'm pushing the same point again. It's the optimizing the operational cost. So uninterrupted water production, high availability, and the reliability due to the high standby rate and other things. This could be a great concept. From 2005, we built all our large installations. Unless it is not allowed by the client, we have adopted this concept. So even the SOREC 1, we have the pressure center design concept in place, and so it's like from 330 MLD to 624, and all in between, we have this concept in place. And can we go to next? So this is the specific energy for this particular the plant, the Echelon, the case study we have picked up. This was the being first. So the specific energy was brought down from 2.7 kilowatt hour per meter cube to a 2.68. So around 2 to 3% of the saving is quite significant, resulting saving only on the RO operation. So and associated the maintenance and other things, given the smaller number of trains and smaller number of pumps, could be an advantage. Can we go to next? While we are pushing the boundaries every day, and thanks to team working at in India, at Noida and Israel, it's like, if you see the trend, it's like Echelon 2005 to IDU ProGreen, we are almost down 2.8 kilowatt hour and less today for the entire plant. It's not just RO. So this is what the promise of an ID in terms of the optimization on the energy. Can we go to next, please? So now the next part, one is the cost, other is, as I said, the convenience. When we talk about the operation on ground and more unregulated environment, greenfield projects, or sometimes the upgradation of the existing sites, it offers different challenges to a developer, to a technology supplier like us. And we always see that there is the trade-off between the cost and the convenience, sometimes the trade-off between the speed and the quality. So it's always a dilemma to how to attend this. And So we again adopted this concept, and I'll take up the case study for the plant in California, US, the Santa Barbara. Though the small plant, but it was a very important building brick for us to introduce the modular plant design. And yeah, please. Thank you. Go to next. Yeah. So this was like 10.5 MLD and 3.5 MLD into 3, which is pretty simple, small, straightforward design. But this was, you can say that this was factory built RO plant, the seawater RO, and shipped from manufacturing location right at the site. As I said, this was more of an upgradation of the existing unit. So a lot of groundwork needs to be done at site and a lot of removal of those old equipments. So with this particular design, we could achieve the simultaneous action. One side, the prefabricated full design is getting ready in the plant. Another side, the site works were on, where the finished ground level preparation were on. Can we move next? So some of the pictures can, when we say these are the the layout, so nothing left to the site, everything, even the smallest of the bolt been designed and installed at the factory in the soft floor environment. Can we move to next? So these are the live pictures. Please go next. Yeah. So we can see the side by side, the site works are going on and the prefab is at the full swing. Yeah, can we go to next? So this is, once the floor is ready, it is very, very quick. These all are modular. One is like fitting comfortably into 40-feet container, and you have to just bolt the skids. This is multi-level design. Can we go next, please? So this is under the movement. The plant is ready and actually ready for the shipping. So what we are trying to do here, it's like, yeah, stay there. So it's like one aspect is we can adopt the best practices on the design, and second aspect is how we can really localize the whole, the manufacturing. At the same time, don't lose the quality. So this is, again, I said it's a dilemma, and we really figure this out as a solution. This plant got commissioned in 2017 successfully, and all our larger installations now move to the MPD configuration. So when we have built around 600 MLD of desalination in India, including the public and private, both thermal and seawater both, we are yet nimble and adapting to the local conditions. And so it's like our promise to India as a Israeli company, considering the all-weather ally for India. It's like this technology is fully indigenized here, and complete sourcing and local manufacturing is in India. So it's like when we are building the critical infrastructure on the desalination, as Devesh rightly mentioned, it is not just about technology, it's also about the peripheral conditions, the political environment and the framework. So we also hope for the best. This session really deliver great momentum, and I wish great luck for the question answer and for the 4 days of the events. So thank you so much for this opportunity.
Thank you, Mr. Shah. Thank you so much. Okay, so I guess we can continue with the session. Unfortunately, we ate up the 10 minutes that we had allocated for questions and answers, but I will invite the Dr. Sarso and Miguel Angel Sanz and Mr. Shah to stay and stand by behind us in case there may be some questions for them. What I would like to do now is trigger some questions. I would like to invite back to the to show their video to the participants. The Honorable Fatma Wale, Jose Diaz Caneja from Acciona, Devesh Sharma, Mena Sadek, Sergio Salinas, and Dr. Anand Vashi. And I will let just, I've been looking at the questions. There's plenty of people looking at this presentation. I got something like almost 100 questions, and I've been trying to answer some of them. Some of them are very technical and very detailed, and I won't be able to answer them so quickly today. So maybe you need to get in touch with us somehow or someday There's some specific questions about Egypt, about the pressure center design and all that. I'll try to bring them up, some of them. But let me do, I've got a lot of questions about energy, a lot of questions about sustainability, plenty of questions about price. So let me just make a short introduction that will trigger questions. It will be 3 or 4 slides. So let's move to the next one. We've seen this problem characterized, which is basically by 2025, we will have 2.8 billion people, many of them in India, having a problem of access to fresh water. We saw the image at the beginning that was showing us the freshwater capacity around the world. But what we didn't see is that we are surrounded by seawater all over the world, and we need to get to use that. So basically, the only answer to this problem is 2 ways, just like Carlos said before: desalination and reuse of wastewater. Next slide will tell us a little bit. Let's see if it comes up, about the industry that we have been creating over time. You see that the capacity of desalination has been doubling and will double again in the next 12 years. And what this means is that we are creating an industry that is extremely competitive and has an impact on price. Many of the prices that you've seen, and we will discuss during the panel, is connected to very large desalination plants that have economies of a scale. But in general, what we see from this graph is that price is coming down, technology is improving, plants are much more reliable, and we have a solution that can be applied to basically any location around the world, small, medium, and large. The next slide will show us a little bit about what is important for a desalination solution. And I think it's in this precise order from the questions I've been getting from the audience: price, reliability, and sustainability. And in this order, because probably today's world, nobody wants to pay more to be sustainable. We don't need to. We have developed enough capacity and enough knowledge to make the plants sustainable. And there's been a lot of questions going on in the background about brine disposal and brine management. And we'll get some of the panelists to talk about brine mining, which is something that is what is now in fashion and something that we're looking at. So water price, as I mentioned, extremely competitive market, economies of scale, water prices coming down significantly, and is related to advances in general, but mostly to energy consumption. Plant reliability, this is sometimes the only solution that we have out there. So we're using very high quality materials. Note that in desalination, a plant is designed for very high corrosive environment and very high pressure. We're working at very high pressure. So make sure you use the right materials, make sure this plant lasts. Sometimes, and I understand that India sometimes is a price-driven market. In desalination, cheap can become very expensive. So don't go for the cheapest solution. And this is coming to touch on the business model that Deves and a few others mentioned, the procurement models. Typically, if you buy water instead of buying a water plant, you're transferring the risk of producing water and looking at the life cycle costing to somebody who knows about desalination. So consider procurement models, consider choosing the right partner for your desalination plant. And then digitalization and monitoring and predictive maintenance is something that is coming. We use data to make desalination plants better. Finally, environmental sustainability. And I'm making this point to trigger questions for the panel and discussions around the panel, and we can talk about this. So the next one is just a couple of questions that we got from the audience. What can we do to improve desalination? Can you move to the next one, please? What can we do to improve desalination and reuse? We can talk about renewable energy connected to desalination. We can talk about graphene. Somebody mentioned graphene in one of the questions. We can talk about technological advances. And one question for the panelists that we have here representing India, which are 3. What are the key elements to make non-conventional water resource facilities successful in the Indian market? So let's remove the presentation and show the panel and start discussing this. I'm gonna let probably the ladies start. I'm gonna go to Fatma Awale, who wanted to give us a little bit of the experience in Mombasa and in Kenya. And there were some specific questions about what is going to happen in Kenya with the desalination plans that have been announced. Fatma, please.
Thank you, Borja. Good afternoon to everyone. Good morning for those partners of ours who are in America. Indeed, it's a great honor to be here today to speak about the Kenyan experience and mostly Mombasa County. In terms of water, I think my colleagues, they've given an indication of what is happening in Egypt, what is happening in India. And in these parts of Africa, the water situation is even worse. For example, we are grumbling with almost 400 million people not having sufficient water. And in Mombasa County, I'll just give an example whereby the demand is over 220,000 cubic meter a day, while what we receive in Mombasa County is approximately between 45 to 50,000 cubic meter a day. So there's disparity of water all over Africa at large. And despite all this, Africa and in particular Mombasa and in Kenya, we're looking at alternative use of trying to inject more water into our country and into our counties. And the only alternative we have, for example, for Mombasa County is the desalination. And in other parts of Kenya, there is the water reuse opportunities. But when you look at the water reuse opportunities in Africa, there is a very strong stereotype about it. This is water that we have been using for other businesses. How can this water be cleaned and completely be cleaned for drinking? Countries like Spain, as our presenter indicated, some of this water reuse is being injected back for agricultural purposes. And when we look at our countries in Africa, we are also bogged down with a lot of bureaucracy in terms of inviting new investments. Mina talked about the collaboration between the Egyptian government and private investors to come in to help to elevate the water shortages. She talked about Egypt relying on the River Nile. By the way, just to mention, there is a lot of issues going on between Kenya and Egypt and Ethiopia in terms of the sharing of River Nile. So you can see there is continuous conflicts when it comes to discuss commodity. And Kenya, as a government, we are trying to improve the water sector and trying to engage the private sector to come in. I saw one of the questions that was being asked by the panel, the audience, was why has the Mombasa desalination, for example, has delayed? And these are some of the bureaucracies that we keep talking about. And at first, the government, I think it's the fear that desalination is very expensive, but Carlos mentioned in his presentation that desalination is now going to almost around $0.5 per cubic meter. But we also lack a lot of, how should I say, a lot of education in Africa at large in terms of what is desalination, what is water reuse, how can this elevate the problem of water in the countries in Africa. We are trying as a government in Kenya to try to improve, to ensure that water is accessible to everyone. And I think the COVID-19 has really magnified in terms of the scarcity of water. It was mentioned by one of the panelists that one of the key factors for COVID is you have to wash your hands every time. But when you look at it and equate in our areas, some of the slum areas where there's no water, this becomes very difficult. Recycling has been tried in Kenya, but there are all these environmental issues. For those who've been watching what has been happening in our rivers and everywhere else, there has been a lot of pollution, and that's why I said again, the stereotype behind reuse is something that I think African countries, we need to really sensitize our population. The alternative of desalination and what was mentioned again in terms of brackish water, incidentally, like Mombasa County borders Kilifi, it borders Kwale County, and these are a source of water in the county. And most of the areas, like in Kilifi, what they're doing is borehole water that is slightly treated and then distributed to the other counties. And we have like a spring, Zima Spring in Taita, that does the distribution to county government of Mombasa. But still, that is still not sufficient in terms of trying to ensure that the population, for example, of Mombasa County has the water, and according to the World Health Organization, and it's a human right for everyone to have water. Now, when we look at the challenges that face us in Africa at large, I had mentioned that, for example, in Kenya, we have a population of 48 million. You heard me mentioning that we're already having conflicts with Egypt when it comes to River Nile. But there is also a lot of conflicts within the counties in Kenya in terms of water. Then when you look at the COVID pandemic, again, it's the backdrop of increased humanitarian needs due to back-to-back drought, floods, and all these other problems. But the main challenge for us in terms of moving forward is how we can have a sustainable, cost-effective means of water to our population. And taking an example of Mombasa, as Borja just mentioned, that we're all surrounded by seawater. How can we utilize this seawater? What are the things that we need to do to attract more investment in Kenya? What are the bureaucracies that we need to do away in terms of inviting investment? And you can see that in Africa, I think it's lack of governance, lack of policies that are in place. And most countries in Africa, and especially in Kenya, I think I've mentioned in previous discussions that water is controlled by the government. You can only charge at a certain rate. So when it comes to alternative methods of water, like desalination, most governments do share away, because I've already said it's a human right. Every country has to provide water, but I think with more sensitization, like in Africa, Nina talked about smaller desalination plants. We can only talk about big desalination plants in countries like Namibia. Algeria is following suit. Morocco is also doing the same. But especially in this East African and central part of Africa, most countries are shying away because they think that desalination is an expense. But what we can see and what has been presented today is desalination and water reuse is the only alternative to be able to mitigate the water shortage in Africa, and especially in Mombasa County. Thank you.
Thank you, Fatma. Thank you very much. We often say in our desalination industry that the most expensive water is usually the one you don't have, and the one that prevents business growth, the one that creates situations with health and problems like that. Mena, you've been mentioned a few times during what Fatma was saying about the sharing of the Nile River. We've seen a few questions also about whether Egypt is going to do also reuse, and whether Egypt will be able to do small and medium desalination projects and not very large ones. Can you give us a little bit of your insights?
Sure, thank you, Borja, and thank you, my dear friend Fatma, for very insightful remarks as usual. Yes, we do share a lot of problems in Africa, and we also share the River Nile. Maybe in my presentation, I briefly mentioned and go into the detail of the Grand Ethiopian Dam and the water sharing problem. I think it's rather political, and what's clear here is that there is no plausible, or there is no near-term solution to the problem around the Nile River. And the scary fact is that we do rely on the River Nile to provide us in Egypt, where we have more than 100 million people. So the Nile River, 100 million people are relying on the Nile River to provide 80% of our needs, and thus the gap created. So with the Grand Ethiopian Dam, this is even more difficult of a situation for us. But even without the conflict, if we assume the conflict is resolved, hopefully, inshallah, as we say very soon, but even without this problem, we still have a water scarcity problem. The solutions that we've seen, so we've seen a lot of, as you mentioned, Borja, smaller desalination, private desalination capacities, but also water reuse is very important. So I've seen the questions about that, and my presentation was more focused about desalination, although water treatment and wastewater treatment is a very important part of the equation to solve where we are today. It is challenging to like Fatma mentioned as well, it is challenging in our culture to convince populations to reuse wastewater, for example. So it's not, it hasn't been an easy process. However, I do believe that this is a completely new process for us, whether desalination, which is perceived as an expensive solution, especially in a country like Egypt, where water is clearly subsidized. So yes, desalination is perceived from the cost perspective. And when we go to water treatment, wastewater treatment, and water reuse, which is people perceive as a cheaper solution because of the cost for some of the existing facilities, there is a cultural barrier about using this water. So I believe we're in for a longer term or a medium term education process for everyone, basically, to understand how we should be tackling this problem. And I believe it will be, desalination is not the only solution, of course. Wastewater treatment and water reuse is definitely part of this solution. It will be an integrated solution. So for instance, coastal cities, it makes a lot of sense to use desalinated water, but all over Egypt in non-coastal cities, water treatment has to be an option. So this is another very important fact that we will see coming out more. So although the focus today was on water desalination, I believe water treatment is a very important part of our solution in Egypt, and you will hear a lot of plans about it, whether new facilities or the refurbishment of existing facilities in Egypt. This is also coming up on our agenda as a country.
Thank you, Meno. Thank you very much. Let me move to India. Let me ask Dr. Anand Vashi his view on the country specifically. What are the specific issues that they see, and what are the potential solutions in general for desalination and reuse? Dr. Vashi.
Yeah, thank you, Borja. First of all, I would like to appreciate the initiative taken by IDA and Water World. Yeah, Smart Water and Water World for arranging such an innovative webinar. In Indian context, I think, see, you know, the population, it's a 1.3 billion. First of all, people must be aware about that in the morning, what they flush, where it goes, what is the sewage, and what is the treatment of the sewage. That awareness program is very important. So that's the first initiative government should take, that what is the wastewater and what is the water. It's a basic difference they must know. They must understand that lots of energy required, lots of cost for the chemical, lots of cost to operate the plant is required for the wastewater treatment. And then the next step is to make them understand about the reuse, not only community, but also the industries and also the government authorities. I will give the one example of case study for the Surat city. We are the first Indian company who has designed and executed 40 MLD capacity tertiary treatment plant. So it's a municipal sewage reuse plant in year 2014. So you can see the win-win situation, that we establish a plant in rupees 18 rupees per kiloliter for the Surat Municipal Corporations, whereas that water is being sold to the nearby textile industry at the rupees of 22 per kiloliter. Yeah, and if the industry purchase from the government cost is rupees 25 per kiloliter. I am talking about in year 2040. Now at present, in 2020, the municipal corporation is selling the water of 40 million liters per day capacity to textile industries at rupees 28 per kiloliter, whereas government charge is 38 rupees per kiloliter. So it's a best sustainable example of municipal water reuse. But the challenge is what we have faced to set up a successful benchmark in India, that when we started the commissioning of the plant, we found the lots of industrial ingress in the sewage, because the existing sewage treatment plant is the source of the tertiary treatment plant. So we found, we observed and we faced the problem of falling of ultrafiltration membrane. And you know the business as usual. The membrane manufacturer always say, oh, sorry, we cannot guarantee because we have designed the flux based on by assuming whatever the data is given in the tender documents or say as per contractual agreement, it's a pure domestic sewage, you know. But here you are getting an industrial ingress and we don't know what are the contents getting mixed with the sewage. So what we have faced the challenge is the lack of R&D facilities, even with us. So we had called many scientists from the Singapore as well, from the Germany as well. And then we have worked a lot based on the available problem. As a EPC contractor, we can run away from this issue because as per contractual agreement, I am not supposed to bound give the design parameter and the design quantity to the customer. However, we have taken this initiative just to create the successful benchmark. And after lots of R&D, we have tried UF membrane of many manufacturers around the world, and finally we have arrived at the successful conclusion. And till date, the Surat Municipal Corporation has generated more than $20 million US. It's a revenue, So it's a successful benchmark for the developing country like in India. And after the success of that project, we have been awarded 2 more projects of similar capacity, each of 40 MLD. So at present in India, we are operating 3 plants of 40 MLD capacity based on the tertiary treatment, UF and RO system, and corporation is generating revenue. So it's a great model. So I think EPC contract is a challenge. What I suggest that political will plays important role. After that, bureaucrats working in central government or say state government and the local semi-government body as well. So whatever they need to plan, they have to plan in advance. They have to understand the need in advance and then appoint a consultant, because now here the consultant plays a very important role. There should not be the business as usual. There should not be the lowest price scenario, or say that is the condition that whoever gets the lowest just get the job. So that lowest L1 bidder, or say even in the consultancy services, I think government should take an initiative to optimize the policy and forget about the lowest price consideration to select the appropriate consultant. Because sometimes what I observe that local consultant may not have that in-depth knowledge, so pre-feasibility report may go wrong, and at actual the scenario may be different when you start the execution. So I think consultant plays important role. So government needs to understand the importance of the selection of consultants, so that consultant select the appropriate technology,
Very good point. Yeah.
appropriate design consideration. So these are the practical issues which is not written in the book. Yeah, that is what we have experienced from our 40 years spending in the water field in India. So that is number two. And number three, the last thing is maybe the IDA chairman, Mr. Carlos Cousin, may be happy to listen that I suggest the PPP model. Yeah, India is in transition phase from EPC, hybrid PPP and the PPP model as well. Because in the PPP model, if you have a strong concrete water purchase agreement with the government, you are flexible to adopt the relevant technology. You are flexible to adopt or say change the technology, say after 5 years, depends on the needs of the water. So that flexibility at private contractors, risk and cost. So I think in long term, say 20 years of period or say 25 years of period, government, may go with such kind of model. So such of, important things, keep it in mind to make all these things successful in India.
Thank you so much, Anand. Very good insights. Let me just say we have about 15 minutes to go. I'm going to give the voice to Dr. Sergio Salinas and then Jose Diaz-Caneja, who have not been able to discuss or present before. And then raise your hand if you want to say something important. Sergio, please give us your insights on desal reuse.
Thank you, Borja. It's a pleasure and an honor to be here among all of you. I'd like to acknowledge first the invitation of the Netherlands Water Partnership for participating in the event. And I think our ambassador has already left the meeting, but it's a great honor that Mr. Vandenberg was present preceding the ceremony. Well, perhaps the Netherlands is a country that is world known for the water cycle, for the water innovation in the water technology sector. And the place where I work, IHE Delft, we work in the business of education at master and PhD level. And I think Mr. Menatala Sadek was mentioning that education is a key factor for the sustainable implementation of desalination plans, desalination projects. We like to contribute with by educating water professionals from all over the world that can be trained in the desalination sector, so that there is no so much dependency on large companies, but there is also a kind of critical mass at national level that are able to implement and monitor and successfully implement these desalination projects. It's our perception that desalination is not the first solution or should not be considered the first solution, but perhaps the last resort. I think when we talk about increasing the water demand, we should also consider well, reasonable use of the water resources we have available. We should consider saving the water that is already treated by, for instance, minimizing non-accounted revenue water in distribution networks. We should also consider perhaps transport of water from different locations in the same country. Depending on the geography, perhaps Aquifer Recharge could be considered an option. It's implemented in many countries in the world successfully. And perhaps another alternative is water reuse. And water reuse is more and more a priority in many countries. It's still with lower cost than desalination, but it also requires know-how on how to successfully operate this kind of water reuse plants. So for us, desalination is a perhaps drought-proof, climate change-proof, infinite resource that is available for providing drinking water. Another important aspect of desalination is not only the quantity that can be produced, but also the quality of the water that can be produced. Reverse osmosis, a mature technology, is able to remove not only salts, but nowadays more and more medicines, micropollutants, microplastics are more and more present in our water resources. So with desalination, we can also provide quantity and quality that is of the best quality. I think it's very important to have a successful partnership of all the water players that are involved in the desalination sector, municipal facilities, the decision makers, the engineers, so that there is a clear understanding of all the implications of desalination, not only for cost, but also for technical capacity, different types of pretreatment technologies, monitoring systems of the water quality. And so desalination, it's a technology that it's mature, it's available, and I think the IDA plays a very important role on disseminating all the knowledge that is already available in more than 20,000 desalination facilities all over the world. Those are 20,000 successful cases of desalination plants, not only of seawater, but brackish water and water reuse. Thank you, Borja.
Thank you, Dr. Salinas. Thank you very much. And thank you for indicating that IDA, which is a not-for-profit organization, can help support the industry. Jose Diaz-Caneja, CEO of Acciona Agua, please go ahead.
Thanks, Borja. Well, thanks for the organization on arranging this webinar. I think it's been very interesting, and I'm very thankful for being able to participate in it. Well, just I was going to mention several of the topics that have been already discussed, and just would like to insist in a couple of them that I found them really relevant on this. No, and Borja, I like the way you started the conversations. The three main aspects would be price, reliability, and sustainability. I think that in terms of pricing, and especially over having in mind what we have seen over the last 3 years, we are reaching at a level that, well, we have been saying that for the last 1 or 2 years, 1.5 years. And each day we are seeing prices going down and down and down, specifically in the Gulf region or in the Middle East region. I also agree that this cannot be transferred directly to other places in the world, because there are many specific aspects that should be taken into account when you form the price and the tariff of desalination. But seeing that we were probably, I don't know, 4 or 5 years ago in a range of 60, 70, 80 cents of dollar per cubic meter, and that now we are seeing offers in the range of 30, 20, high 20s, that still needs to be developed, but in the mid 30s, we are seeing something, and definitely in the 40s. So these things and this benchmark now is giving the opportunity for diesel to be much more widely spread around and used and utilized in many more opportunities and projects. I think that reliability nowadays is out of doubt. I think that, like Sergio said, there are over 20,000 desalination plants working worldwide. And I think that everybody could now check that these facilities are working well, and that has been a step forward compared to the previous technologies, even or also in terms of reliability. Sustainability, that for us at our group, Fiona, it's a core word, it's a core aspect of our daily activities, and not only in water, but in renewable energy or even in infrastructure development. And we also understand that that this is out of question, even if, unfortunately, sometimes desalination is being used as a political tool to fight between the different parties. But the funny thing is that these parties change their mind depending on which side of the table they are sitting. So I wouldn't pay a lot of attention to that. And definitely there are aspects which we could discuss or argue, mainly the energy consumption, also the brine discharge. But if you compare this to the need of having water, having fresh water, and as you say also, Borja, I think that these topics are not really relevant if they are performed properly, and there are many ways of doing that nowadays. An important question that also linked with the previous speakers in terms of reliability and the importance of adequate consultancy advising and going seriously through the full procurement process. I would say that this is not, even if it's reliable, and nowadays we could depend on that, and several countries are doing that. This is not, let's say, easy technology to be put together. I mean, there is a lot of know-how, and proof of that is that there has been also some defaulted projects, and some of them have given quite bad reputation to the technology in the past, probably more than it was needed, and we all need to fight on that. We also seen that probably the main 5-6 players worldwide from 5 years ago to nowadays have not been the same. So some ones are coming in, probably not really specialized in the technology, but general contractors that have seen an opportunity in this market, but also other companies that unfortunately has been left in the road through financial problems or bankruptcy or issues, mainly related to the tough competition that we are seeing nowadays. So my recommendation to anyone that is willing to develop a relevant project in desalination is that he should get the right advice. He should screen the market to see which are the players and what's the type of project he wants to be developing, and doing a thorough study before entering in the details of the tendering process.
Thank you, Jose. I agree. I think I mentioned that already, that be careful, because cheap in desalination can turn into expensive very quickly. And
yeah,
we're supposed to build plants for 25-year life. We're supposed to look at the whole life cycle costing. And if you buy cheap, sometimes it becomes really expensive. Okay, we have 6 minutes. Anybody that has something pressing that is relevant and important for the audience to hear? Speak now.
Borja?
Yes, Domingo, go ahead.
Yeah. I had bad news for the people asking about energy and new technologies. Energy represents more or less 60% of desalination costs. And currently there is no many space for reducing it, because we have a strange thing that is called the laws of thermodynamics, which is very complicated to reduce more the energy in our plants. This means that we have only some opportunities, for example, using renewable energy in order to reduce the CO2 footprint. We can improve some small steps in our energy consumption, maybe using storage and production operation strategies in order to use more favorable tariffs, but this is complicated. And speaking about new technologies, it's not expected that RO can be replaced for other things, such as the graphene or other innovations you can hear about for this problem. We have the laws of thermodynamics, the limit for the desalination, the energy consumption for desalination is close to the limit, and then it's very difficult to reduce to reduce too much. No?
I agree. And going against the laws of thermodynamics may be very disappointing for anybody. Huh?
Yeah.
Deves, go ahead.
Yeah, I just want to add a little bit to what Domingo's saying. I agree with him from a scientific point of view. Is theoretically, we've had a lot of technology development and making huge strides on energy with related to RO is going to be a challenge. But in the practical matter, we talk about 2.8, 2.5, 3.0, 3.5, but the reality of the matter is most of the desalination plants operating in the world are much higher because of all of the antiquated procurement processes and buying, as you said, cheap. There's a difference in the energy consumption of a desal plant in year one and 5 years, 10 years down the line. There's a degradation, and that's where there's a lot of work today to improve the operations. So there's still a lot of opportunity in improving the cost of desalination from that point of view. So I just wanted to mention that. And just, as far as the cost, we have a very challenging role in this industry. Water is one of the only commodities that as it gets scarcer, it doesn't get more expensive. So we're dealing with two bookends. One bookend is of water scarcity hitting us like a freight train, particularly in India. But on the other hand, I think Fatma said it well. It's a human right. We have to make it affordable. And right in the middle of that is government. As these water problems become more complex, the collaboration of private industry and government is critical. I specifically chose my words carefully. I didn't want to say PPP because when we say public-private partnership, we get into tendering mode. So, we're not saying a kind of a closed two-way dialogue. A real collaboration is needed to solve these challenges. And I think that's what we're trying to do in the IDA.
Thank you, Deves. Miguel, you look like you want to say something.
Thank you. I think that's as Domingo was saying, the energy is not the only important thing because we are very close to the minimum we can optimize. But of course, they just reduce the price is a target, but it's not the only one. I agree with Deves because in the majority of the case, we are not treating the price we have in Middle East, using the very low price coming from the energy. That's not the case in the majority of the world. I think for the rest of the world, one the thing is important just to optimize and increase the reliability of the desalination plant to be more affordable, because now we are very close to the cost of a conventional drinking water. So I think it's not a question just to save still 2 or 3 more times. I think it's a question just to spread the solution, just to promote it and doing it more sustainable. So the environment is must be a target, and also all the sustainable solutions we can apply just to avoid any disturbance to the environment. One of the more difficult things we have in desalination is time to time we have some news saying there is a toxic brine or things like that. I think that is not very good from the industry because it's not really true. So I think we need to invest a lot of things just into train the people, to spread the knowledge, to spread what is really a very good and sustainable desalination, and optimizing all the operating costs. Still, there is a lot of things to do in the pretreatment, just to minimize, to reduce the chemicals. Chemicals is also a carbon footprint from the plant. So we need to optimize the carbon footprint, not only by the energy point of view. Thank you.
Very good point, absolutely. And I've been getting some questions throughout this session, these 2-hour sessions, that were indicating that there are some misconceptions out there about desal. So when there are misconceptions, come to the experts, come to IDA. We can help with all those misconceptions. I'm going to thank all of you for today's participation. It's been wonderful. I think it's been better than even I expected, and I knew most of you. I knew you would be excellent. I'm going to pass on the floor to Shannon McCarthy, Secretary General of IDA, for the closing remarks. Thank you.
Good evening to everyone in India, and good afternoon and good morning to others participating in this webinar. On behalf of IDA, I'd like to thank the team at Smart Water India for their excellent organization of this event. It's been a pleasure to work with you to curate today's desalination session. I would also like to thank Ambassador Van den Berg and Honorable Ovink from the Government of the Netherlands for their opening remarks. Many of us know the Netherlands has always prioritized water and for many years brought the international community together to discuss sustainable water strategies and the sustainable development goals and challenges put out and put forth by the United Nations. They've also made significant investments in helping countries address water needs and capacity building through their development programs like the one they support at the Middle East Desalination Research Center in Oman. Our moderator today, Mr. Borja Blanco, has done a wonderful job in keeping the program on track and leading a dynamic panel discussion, so thank you, Borja. As well, I would like to thank all the distinguished speakers and panelists from around the globe for sharing your knowledge and experience with the audience today. We went through various examples of non-conventional solutions installed or being installed in the Middle East, Europe, the USA, and Australia. I hope those have given everyone some food for thought on how to approach solutions in India. It's my pleasure to highlight the various points we shared today in this webinar as a concluding remark. So let me summarize them as follows. Water is scarce. It's a scarce resource directly related to climate change via the floods, droughts, and migration. The effects of climate change we see today are only going to increase, and therefore we need a proactive approach, a pre-crisis approach as put forth by our colleagues in the Netherlands. Collaboration is key, and we need private and public collaboration, institutional and international financial agency partnerships to meet these challenges. The water demand gap can be resolved with non-conventional water solutions, as pointed out by our president, Mr. Kozin. Desalination solutions are becoming more affordable when the right business model and technology suite is selected, pointed out by Devesh Sharma. And when possible, a blended strategy is critical to achieving balance and reducing prices, as the example was given today from Dr. Zarzo from Spain. To conserve our natural resources, expansion on a global scale of water reuse for industrial and irrigation uses is highly needed. And we are looking into that at IDA. We will soon be conducting a 6-part webinar series on industrial water reuse. So we invite everyone to join that. The first is on October 14th. But we also have to look at regulatory frameworks for water reuse, and we need to enhance and expand those frameworks worldwide. And we will address that in our March conference in Rome on water reuse and recycling. And of course, you're all invited to attend or participate in some way. If we are not able to do an in-person conference, we will take that conference virtual. And then it was mentioned quite a few times, the point of innovation in our sector. One of those interesting points is on ocean brine mining for precious and reusable minerals and salts to lower the cost of desalinated water indirectly. It would do that. So other technology trends like zero liquid desalination and digital innovation are making a stronger impact on efficiency of the facilities that are running today and being built for the future. And as we did today, we at the IDA are continually working to bring all the stakeholders together And at the moment, we have several open calls for papers and extended abstracts for the following conferences. As I mentioned, that is Rome Water Reuse and Recycling Conference, March 15th to the 17th, 2021, an Ocean Brine Mining Symposium in partnership with the Saudi Water Conversion Corporation in Saudi Arabia on October 28th, 2021, and an IDA World Congress, which is our biennial event. And we hope if you have not attended, or even if you have, that you'll come back to join us in Australia, in Sydney, November 7th to the 11th, 2021. So there is, if you go to the IDA website, which is idadesal.org, you can find information on how to submit an extended abstract to any one of those events. And in general, I'd like to just thank everyone for your participation and our colleagues from IDA. We have a wonderful board of directors, as you've seen today, just a few of them participating. There are many. And so we hope to be closer to you and going forward in the future. So thank you to the organizers. Thank you, Mr. Kalish. Thank you, Bakshar. And thank you again, Borja, for moderating. With that, I think we can pass the floor back to Kalish for a closing remark on your side and close out the webinar today.
Thank you, Shannon. This brings us to the end of day one of India Water Information Week. We would like to thank the International Desalination Association for all the support they have given us to make this event a success. So thank you, Shannon, for this. We will have day two, which is on digital water, tomorrow at 3 p.m. India time, because we have some speakers from Australia and Singapore, and we needed to prepone the session to fit them in. So with this, I bring the day one to an end, and I will hope to see all of you tomorrow at 3 p.m. Thank you.
Thank you very much.
Thank you very much.